Hi there, and thanks for tuning in. Today we're going to be looking at lesson 3.3, function notation, and today we're going to be looking for 6 things in our notes. There are about 4 different things that we're going to be covering, so there's 4 parts of our notes. Let's go ahead and get started. First thing we want to look at is what we're going to be seeing in today's notes. Number 1, we're going to be seeing how to evaluate a function. Number 2, we're going to be seeing how to solve for an independent variable, so kind of like what we did in chapter 1 when we were solving for x or for y. The other thing we're going to be doing is interpreting a function. So what does it mean whenever we have certain numbers? And then number 4 will just be graphing. Next, what we're going to do is actually write down really quickly just a representation of linear functions one more time. A linear function can be made with the equation y is equal to mx plus b. Function notation can also be doing that, except you just replace y with f of x or g of x or h of x. Okay? And f of x is just another name for y, so you're not changing anything, you just have to get used to seeing that f of x there. And again, you can use letters other than the letter f to name a function such as g or h. So let's go ahead and just take time now to pause right here so you can write down what you see on the screen, and then once you're done, click play so you can see how it's done. Sorry about that. So what we're going to do is evaluate a function, and these are pretty easy because all you're going to do is just replace x with another number. So if I replace x with 2, it'd be negative 4 times 2 plus 7. That's going to be negative 8 plus 7, which is equal to negative 1. And if I replace it with negative 2, that'd be negative 4 times negative 2 plus 7, which is positive 8 times 7, and that gives me 15. So my two numbers are negative 1 and 15. So here are some that you're going to try. This one you're just going to replace x with negative 4, 0, and 3 to figure out what the function would be once you replace it. So let's go ahead and pause the video here so you can try it, and once you're done, click play. Alright, if we replace x with negative 4, we're going to have negative 2 times negative 4, which is negative 8, and negative 8 minus 5 would be negative 8 plus negative 5, which is equal to negative 13, so that's one answer. The next one, when we replace with a 0, we get 2 times 0, which is 0, and 0 minus 5 is negative 5, so negative 5 is another answer. And then when we replace with 3, 2 times 3 is 6, and 6 minus 5 is 1. So here are my 3 answers whenever I replace negative 4, 0, and then 3. Here's another one we're going to try. Again, you're just going to put in negative 4, 0, and 3, but this time we have the function g of x is equal to negative x minus 1. Be careful with this negative that's already there in front of the x. Let's go ahead and pause the video now so you can try them by yourself, and once you're done, click play. Alright, so after I plug in all of the x values, this is what they'll look like. Notice in the first one, a negative 4 just changes to a positive 4, so 4 minus 1 is 3. The next one we have is 0 minus 1, and that would just give you a negative 1, because 0 really just can't be negative, so you're really just thinking about 0 minus 1. And then the last one, 3 minus 1, which would just be negative 3 minus 1, which just means negative 3 plus negative 1, and that's going to give us negative 4. Okay? The next part, part 2, is solving for the independent variable. These are pretty simple because what they're doing is they're asking you to replace a number with h of x, g of x, or f of x. So what I'm going to do is I'm going to replace this h of x with negative 7 equals 2/3 x minus 5. And then I'm going to solve for x. So I'm just going to get x by itself. So I'm going to add 5 to both sides. Negative 7 plus 5 is going to give me negative 2. So I have negative 2 is equal to 2/3 x. And then to get x by itself, I'm going to multiply by the reciprocal of 3/2. And I get negative 6 over 2, or just negative 3. So there's my answer for this example. So this one you're going to try by yourself. You're going to replace f of x with 21 and then solve for x. Let's go ahead and pause here so you can try by yourself, and once you're done, click play. Alright, so when we replace f of x with 21, we get 21 is equal to 6x plus 9. I'm going to start by subtracting 9 from both sides. 21 minus 9 gives me 12. And then all I have to do is divide both sides by 6. So I get x is equal to 2. The next part we're going to talk about is interpreting a function. And these are a little bit tricky, so make sure you pay close attention here. It says let f of t represent the outside temperature t hours after 6 a.m. So if it's 0, it's 0 hours after 6 a.m. If it's 1, it's 1 hour after 6 a.m., etc. The next says explain the meaning of each statement. Well, the first one, since it says f of 0, that means 0 hours after 6 a.m., which just means at 6 a.m. it's equal to 58 degrees outside. Okay? But this one says f of 6, and that means 6 hours after 6 a.m., which is equal to 12 p.m. So at 12 p.m., it's equal to, doesn't give us a number, so we're just going to say in degrees. And then here it says f of 3 is less than f of 9. Remember, this is 3 hours after 6 a.m. or 9 a.m. And then f of 9 would be 9 hours after. Oops. 9 hours after just means that'd be 3 p.m. So that means 9 a.m. Temperature is less than the 3 p.m. temperature. And that makes sense because usually as the day goes on, your temperature increases. So here are a few that you're going to try. So you're going to interpret what does it mean to be t hours after 9 a.m. So what we're going to do is pause here so you can try A, B, C, and D. And then once you're done, click play. So letter A means 4 hours after 9 a.m. So that would mean 1 p.m. is equal to 75 degrees. Okay? This one doesn't tell us the time, so it would be m hours after 9 a.m. equals 70 degrees. For letter C, 2 hours after 9 a.m. means 11 hours, or 11 a.m. And then 9 hours after 9 p.m. would be 6 p.m. So 11 a.m. is equal to 6 p.m.'s temperature. And then letter D, it says f of 6. That just means 6 hours after 9 a.m. That would be 3 p.m. is greater than f of 0. That means starting at 9 a.m. So 3 p.m. is greater than 9 a.m.'s temperature. Okay, so that's all you have to do there. The last type we're going to look at is when you graph a function. So you're given a function here, and all you have to do to graph it is make an input-output table to get your x and y points, or your x and f of x points. So this is what you're going to do for the next example. I pick 5 points, -2, -1, 0, 1, and 2. And that just kind of gets you a good range. So I would make sure to choose these every single time. And all you have to do is plug in each one of those values. So the first one you'd have 2 times -2 plus 5. That's -4 plus 5, which is 1. The next one, if you plug in -1, 2 times -1 plus 5. 2 times -1 is -2. -2 plus 5 is 3. The next one is 0. So if we plug in 0, that's 2 times 0, which is 0, and 0 plus 5 is 5. Next one we have is 1. 2 times 1 is 2, plus 5 is 7. And then the last one, if we plug in 2, 2 times 2 is 4, and 4 plus 5 is 9. To double check your work, it should be increasing by a steady amount. This one is always increasing by 2. Okay? And then you just go over here and plot your points. -2, +1, -1, +3, 0, +5, 1, +7, and 2, +9. Once you're done, you do want to connect your points because this is a linear function because it's written in the form of y is equal to mx plus b. Okay, so that's all you're going to do for number 6. Here it is. Again, I would make your input-output table. Have -2, -1, 0, 1, and 2, just to give you some positives and some negatives. So pausing here to try it by yourself. Once you're done, click play. All right, if we plugged in -2, we should get -8. So that's 3 times -2 is -6. -6 minus 2 is -8. If we plug in -1, we get -5. If we plug in 0, we get -2. If we plug in 1, we get 1. And when we plug in 2, we should get 4. So then I just graph these, -2, -8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, the next one, -1, -5. 1, 2, 3, 4, 5. 0, -2. Oops, probably should scoot this guy over. 1, 1. And then 2, 4. So it does have a steeper line for this one. Your y-intercept is all the way down at -2. Okay, so that's all you had to do for number 6. Your line probably looks a little bit better than mine because it's a little bit straighter. That is going to conclude your notes for 3.3. Thanks for hanging in there with all those 4 different things. And make sure to tune in next time.